Hi there, I'm Sindhu Chengad, Azure Open Source Lead at Microsoft Asia Pacific. Welcome to the second part of Open Azure Day. Thank you for joining us again today. In this part of the event, we will dive deeper into how open source fits into the Azure Data Team's efforts and how the Azure Data Team is working on key technologies like MySQL, Redis, Cosmos DB to help you be more productive and innovative. Now, before we get started, I would like to share some tips so you can get the best out of today's experience. Firstly, we have our Q&A open throughout this event. Please feel free to ask our experts anything. You can do so by dropping your questions in the Q&A widget. On the bottom left-hand corner of your console, you will find a resources list. We have some useful content there for your further consumption. There's also a survey at the bottom. So we'd love to hear what your thought about today's session is, so please take a minute to complete this at the end of the session. In case you missed out the first part of the Open Azure Day, you can rewatch it by clicking on Day 1 event link in the resources list widget. Thank you, and I hope you have an amazing time with us.
I'm delighted to be here with all of you today here at Open Azure Day. Has to be done virtually because, well, that's how it's these days. I love open source, and today I'm going to be talking to you all about open source and Azure data now and next. A bit about me. I'm Sunil Kamath, and I'm part of the Azure data team here at Microsoft. I live in the Seattle neighborhood, and I have been at Microsoft for about 5 years. And I have been working on everything data for over 20 years. Now, as I go deeper into the topic of open source at Microsoft and Azure data in particular, I would like to draw your attention to this following quote from our CEO, Satya Nadella. The above quote underscores the belief in the power of communities. Community makes all the difference. Today's communities are not limited by the corporate boundaries. Of course, open source is super important to the fast-paced development we see today. But most importantly are the people coming together to help each other out. And as the world has changed, Microsoft has gone through its own evolution. With the development and investments we have been making in open source, our commitment to the community is stronger than ever. It's our ability to work together that helps our dreams become reality. And we are dedicated to cultivating and growing communities to do just that. I imagine most of you have your own journey with open source. Whether it's simply using open source software or some contributions, or be it code, or be it anything really, there are lots of ways to engage and contribute to open source. Every little contribution is valued and super appreciated. My own journey with open source started back in Toronto, Canada in 2000. As a database performance engineer working on Linux, my first role out of the college was optimizing Linux operating system for databases to achieve the best performance and scalability. I had the distinct privilege to work on improving Linux memory management, tune scheduler algorithms, optimize file I/O management, etc. The focus and the contributions made by many in the community to optimize Linux for critical workloads such as databases directly led to Linux becoming the mainstream operating system of choice to run databases. That, in my mind, is the power of community as a whole, which is greater than the sum of its parts. Here at Microsoft, I head up products for all our open source related relational databases. Over 3 years ago, I helped to launch MySQL, Postgres, and MariaDB open source databases as a fully managed service on Azure. It has been humbling to see the massive growth in adoption of these services. I'm here today representing all of Azure data, not just my work with open source databases, and not all of Azure, since I definitely wouldn't be able to do any justice, but rather to represent our Azure data team here at Microsoft. The power of data-driven intelligence to change the world is almost without limit. The massive amounts of data getting generated together with advances in AI and the power of cloud are enabling organizations to extract insights in fast and cost-effective ways. And our mission in Azure Data is here to deliver the one data platform that empowers the world to make sense of all of the data anywhere, responsibly, and at any scale. Within Azure Data, we now have comprehensive open source data products ranging from relational databases to Hadoop, Spark, etc. Literally every product or service, we use some sort of open source technology. There are three ways we participate in open source. On our team, the first way is we contribute to existing projects or release new projects. And I will cover just a few examples today in the areas of Spark, Postgres, and Onyx. The second way we participate in open source is to enable all of you. So for example, we make lots of open source offerings available as a PaaS service, underscoring our commitment to customer choice and flexibility, so that it is easier for you to focus on your apps. The third way we participate in open source is that we integrate with open source technologies. A great example here is SQL Server, our own proprietary database, which combines and continues to embrace open source from SQL Server 2017, support for Linux and containers, to SQL Server 2019, now embracing Spark and HDFS to bring you a unified data platform. This also extends to support for Cassandra API, Gremlin API, etc. as part of our Azure Cosmos DB offering as well. The first way we participate in open source by contributing and by giving back to the community. I'm going to walk you through three pretty interesting examples of how we contribute to these open source communities: Apache Spark, Postgres, and then Onyx in the machine learning space. Okay, so let's dive into this super interesting technology that most of you are familiar with, Apache Spark. Apache Spark is a fast, unified analytics engine for big data and machine learning, and was originally developed at UC Berkeley in 2009. And I want to walk you through a few of our recent contributions to this wonderful open source community. You might already know that we invested in Databricks last year. You might not know, though, that members of our engineering team submit quite a few contributions to Spark in the form of bug fixes, improvements, and also features. We open sourced Data Accelerator, a project to help write Spark streaming apps faster. There's Hyperspace, an indexing subsystem for Spark, which we open sourced earlier this year. And then there are all sorts of contributions to other Apache projects that didn't make it into all of this timeline, including our contributions to the Yarn Federation and Project Mercury for Yarn back in 2017 and 2018. And while I'm talking about Yarn, I want to shine a light on the fact that you can contribute to open source communities in ways that go beyond just code. For example, several of our team have been release managers for the Yarn project too. The Postgres community openly describes Postgres as the world's advanced open source relational database. Postgres is one of the most loved open source database, and this community has done a phenomenal job over the years. Next, I want to talk about how we are contributing to this particular community. When it comes to Postgres, Microsoft is all in. Did you know Microsoft now has over 100 plus years of combined Postgres experience in-house? And our 4 prolific Postgres committers that are working hand in glove with the larger Postgres community around the world to improve and make Postgres better with every release. To achieve committer status is hard. It represents their long and distinguished contributions. We are extremely proud of their work. You can learn more about the work that we are doing via the short URL link you can see on the screen. Here's one example where one of our Postgres committers, engineer named Anders Front, focused on analyzing the limits of Postgres connection scalability. He recently published this awesome blog. Now, if you want to understand this problem space, this blog is a great source. Anders also published a post on measuring the memory overhead of a Postgres connection. Anders has been very busy working to improve this and also published a blog on the work he's contributing to the next Postgres 14 release. And this is in the area of how to improve Postgres connection scalability. While I'm on the topic about Postgres, I also want to share about the work we are doing on Citus, an open source extension to Postgres. What Citus does is it transforms Postgres into a distributed database, and therefore you never have to worry about the limits to Postgres scaling. Whether your database size is as small as 100 gigabytes or large petabyte plus, you can benefit from Citus to reduce your query latency, increase your application throughput, while also helping scale database operations such as backup, restore, indexing, vacuuming too, etc. And also, because it is an extension, Citus supports new Postgres releases and allows you to benefit from new features while maintaining full compatibility with existing Postgres tools. And here on the screen, you will see a screenshot of the Citus open source GitHub repo with a short URL to make it easy for you to find. You can download this for free and use it with any community Postgres releases. Another one of our open source contributions to Postgres is the PG Auto Failover, another extension to Postgres from our engineer Dimitri Fontaine. The motivation to add PG Auto Failover was to simplify the management of high availability and failover for Postgres databases. Besides these, we have contributed and maintained several other open source extensions to Postgres, things like PG cron, Top-N, CStore, etc. Check out this link to learn more about all of these. Now let's switch gears and talk about another space we are contributing, in the space of machine learning. ONNX stands for Open Neural Network Exchange. Microsoft and a community of partners created ONNX as an open standard for representing machine learning models. Models from many frameworks including TensorFlow, PyTorch, MATLAB, SparkML, etc. can be exported or converted to standard ONNX format. Once the models are in the ONNX format, they can run on a variety of platforms and devices. ONNX Runtime is a high-performance inference engine for deploying ONNX models to production. It is used in high-scale Microsoft services such as Bing, Office, and also Azure Cognitive Services. It enables acceleration of machine learning inferencing across all of your deployment targets using a single set of API. Okay, now let's switch gears and talk about the second door. That second door, we participate in open source by enabling you to use open source more easily as a fully managed service in the cloud or even in hybrid scenarios. So I'm going to walk you all through 5 different open source technology areas where we are making it easier for you to use open source. Let's talk about MySQL, an open source relational database. Azure Database for MySQL is an enterprise-grade cloud-native managed service using the community edition of MySQL. It offers many built-in capabilities and integrations to help you focus on your application, and also it provides ML-powered intelligence such as query insights, query performance recommendations, and advanced threat protection to ensure your database is fully protected from many of these attack vectors. Recently, in September, we announced the preview of Flexible Server. It's a new deployment option for Azure Database for MySQL. We built Flexible Server because we listened to developers and they really wanted the manageability benefits of a complete PaaS solution, but had a hard time giving up the control of what they could get running in a VM. Flexible Server provides similar level of control and performance in what you would get on a VM, but with all the benefits of a PaaS. Now, isn't that better? Flexible Server is designed to improve developer productivity and help you save costs. Built on Azure Core Compute Networking and Storage, we have added support for burstables that help you get started with as little as $12. You can start databases, instances, and have full control in your hands on when you want to apply maintenance patches, as an example, with the flexibility to deploy with a single or full zonal redundancy for maximum resiliency. You also now have control on customizing several of the MySQL parameters and ability to deploy your database in a managed VNet. To illustrate how easy it is to create a MySQL database, let me show you how you create a MySQL Flexible Server. With this simple one command, your database is created and secured in a managed VNet. If you are into gaming, you are most likely familiar with Minecraft, aren't you? Did you know MySQL is the database powering this? This blog, titled Migrating Minecraft Realms from AWS to Azure, describes the successful migration of Minecraft Realms, which is a Minecraft's private multiplayer server hosting service, from AWS to Azure. It is worth highlighting that this migration process was completely invisible to most players, and their deployment on Azure are now simpler, with more efficient resource utilization and also more flexibility that they have achieved in their architecture. Would encourage you to read this blog, and it has details about the migration planning and also useful tips from the Minecraft team themselves. Let's next talk about Redis. For years, developers have utilized the speed and throughput of Redis to produce unbeatable responsiveness and scale in their applications. We have seen tremendous adoption of Azure Cache for Redis, our managed solution built on open source Redis, as Azure customers have leveraged Redis performance as a distributed cache, session store, and message broker. The incorporation of the Redis Labs Redis enterprise technology extends the range of use cases in which developers can utilize Redis while providing enhanced operational resiliency and security. With the integration of Redis Labs technology with Azure Cache for Redis, customers can now access Redis Labs developed modules including Redis Search, Redis Bloom, and also Redis Time Series, which provides new data structures that will further enable use cases like data analytics and machine learning. Customer will also now have the option to deploy SSD flash storage, offering up to 10 times larger cache sizes and similar performance levels at a lower price per gigabyte. Reliability will be even greater priority with an enhanced SLA and the capability to utilize active geo-replication to configure a globally available cache that can fail over to another region without any data loss. Next up is Databricks, one of our partners and a company we made investment back in 2019. Azure Databricks is a jointly developed data and AI service from Databricks and Microsoft, and is used for data engineering, data science, analytics, and machine learning. Azure Databricks is a first-party Microsoft service to provide Databricks Apache server-based analytics service as an integral part of the Microsoft Azure platform. We have ensured this offering is natively integrated within Microsoft Azure in a number of ways, ranging from a single click start to unified billing. Azure Databricks leverages Azure's security and seamlessly integrates with Azure services such as Azure Active Directory, Azure Synapse Analytics, and also Power BI. Next up is Azure Hdinsights. Azure Hdinsights is a fully managed service for your open source big data needs. With Hdinsights, customers get all the benefits of open source analytics, but with the security, cost control, and enterprise readiness of Azure. Since our inception, we have dedicated to the spirit and the community of open source. Starting in August 2020, we transitioned Azure Hdinsights to a Microsoft engineered distribution of Apache Hadoop and Spark, built to drastically improve the performance and optimize to natively run at cloud scale. We remain 100% committed to open and work with this open source community to contribute our innovations back to the Apache project itself. Let me quickly share the story of a company that offered taxi hailing and food delivery. Their application needed to do real-time data processing that they can leverage to get insights so that they can give their customers better service. You can imagine things like shorter wait times, best possible routes from here to there, food delivery recommendations, etc. Azure Hdinsights has given them a way to manage their big data workloads. Azure Database for Postgres is also a fully managed PaaS solution built using the community version of Postgres. We have made it enterprise ready with advanced security and intelligent performance capabilities that help you to optimize and get the best performance. We are thrilled to see the massive growth in adoption. Again, just like MySQL, which I mentioned a few minutes ago, the Postgres Flexible Server is also a new deployment option, providing similar level of control and performance in what you would get on a VM with all the benefits of a PaaS. Please check out the short URL link here on the screen to learn more. To highlight some of the key things we focused on for flexible server, one was simplified developer experience and performance that helps improve your productivity. Second was reducing cost via burstables and ability to stop and start databases. And third, and more importantly, was full control and flexibility in your hands for meeting your mission critical needs. Okay, so now let's talk a little bit about Citus. I discussed that as part of our contributions already. What I want to focus here is our Hyperscale Citus deployment option, part of the same Azure database for Postgres service. Hyperscale Citus is a fully managed cloud-native development deployment option to scale out your single node Postgres. Underneath, it uses the same open source Citus extension. Here on this slide, you can see how Hyperscale Citus works to distribute your query to run in parallel across all the nodes. This illustration shows 3 worker nodes, and where you can also see that you can add more nodes on the fly. You can redistribute data across all the nodes in online fashion, and while all the transactions continue to execute. I talked about how scaling out Postgres with Citus opens the door to new possibilities. Here is a customer example, Helsinki Region Transport Authority in Finland, on their use of Postgres Hyperscale Citus. It was a whole different environment once we moved to Hyperscale Citus, they quote. Queries that often took up to 10 minutes with the old system are now processed instantaneously. That's the magic of Postgres Hyperscale. Along with much better performance, moving to Hyperscale has reduced operational cost for this customer by over 50%. Another one I would like to reference is from our own internal team here within Microsoft, who uses Postgres and Citus running on Azure. Minwei here says distributed Postgres is a game changer. We can support more than 6 million queries every day on a 2 petabytes of data. With Citus, response times for 75% of the queries are less than 0.2 seconds. Check this blog out to learn more about this use case from our Windows Data and Intelligence team. This workload is powering an analytics dashboard. It captures over 20,000 different types of metrics from over 800 million devices, supporting hundreds of concurrent users. It's a huge deployment, making it possible to make ship room decisions for Windows. Okay, so now let's talk about how we use Kubernetes along with Postgres and SQL Server. Until now, I talked about how we enable open source technologies as a service in public Azure. I would like to share that we have also been working to make these Azure database services run anywhere. A new capability enabled by Azure Arc that allows you to run on-premises, multi-cloud, and also edge. Using Kubernetes as the hardware of your choice. Azure Arc enables SQL Managed Instance and Azure Arc enabled Postgres Hyperscale are available in preview now, with other services to come over time. Check out the short URL link to learn more. Travis Wright, my colleague, has done an awesome job explaining this at more depth. Okay, so now let's talk about the third way that our team at Azure Data participates in open source. How we integrate with open source. I'm just going to cover one example in this section of how we integrate with. Of course, I shared an example of SQL Server earlier on. Here, I'm going to talk about Cassandra and Gremlin. With Azure Cosmos DB, we have protocol level integration. The promise is you can access your data in Azure Cosmos DB using the same framework, same drivers, same tooling that you use to access Cassandra and Gremlin. And then make that data more flexible and scalable to power web applications, recommendation engines, real-time personalization, and also supply chain management. Here you see a large national retailer has used their API for Gremlin with Azure Cosmos DB to ingest large volumes of localization and inventory data. They use this data to power an online product recommendation engine, which is dynamically informed by in-store product availability. Now, in preparing for this talk, I got to discover and learn myself about all the open source activities that our team here within Azure Data are working on. To be honest with all of you, I was pretty much floored. And it's just the tip of the iceberg. There are even more open source projects that I wanted to talk about today, but just couldn't fit them all in. So now what? I would like to draw your attention to other outstanding talks happening at Open Azure Day. I'm sure you will love all of them. As I now begin to wrap up my talk, I want to leave you with a parting gift. a link to a video featuring Stephen Hawking. He encourages to working with communities and raises the importance of open platforms and how it helps accelerate innovation. Although Stephen Hawking is no longer with us, his inspiration and thoughts will forever be with us. Sometimes those of us who work on open source feel like we are standing on the shoulders of giants, that we get so much benefit from the work done by others in the community, so we can build on top of existing rock-solid open source software rather than reinventing the wheel each time. With that, it's now time for me to say thank you for tuning in and listening to my talk. I am leaving you with my Twitter handle. On behalf of my entire team here in Azure Data, thank you so very much.
Hello, I'm Sridhar Ranganathan. I'm a program manager for Azure Database for PostgreSQL at Microsoft. I've been working with relational database technologies, including Oracle and Postgres, for nearly 20 years in both technical and PM roles. I'm passionate about data protection, high availability, and business continuity aspects of databases. Today, I'm really excited to talk to you about deploying and running your mission-critical applications with Azure Database for Postgres. Let me begin this talk by discussing about Postgres and why it is a popular database. I will then go over how Azure builds on top of Postgres capabilities. Then I will discuss few Postgres deployment options for your applications on Azure. And finally, end the talk with what makes Azure the best destination for Postgres. As many of you probably know, Postgres is the world's most advanced open source relational database. Why is it? The primary reason is it's open source with a large developer community, with developers and DBAs love Postgres. Second, it's over 20 years in development with proven resiliency and stability, with thousands of mission-critical applications running on Postgres. And third, it has rich feature sets, right? Such as a lot of data types that you can configure, rich indexing, full text search, JSON-B support, and also extensibility. Overall, by staying true to its principle of being standard compliant and highly programmable, Postgres has really solidified its position as the most loved database. Now, Postgres is more popular than ever, right? At the forefront, Postgres has shown that it's an open source database built for every type of developer. DB Engines ranked Postgres as the DBMS of the year for both 2017 and 2018. Similarly, like Stack Overflow 2019 developer survey revealed that Postgres is the most loved and wanted database. And Microsoft loves Postgres and it's committed to Postgres. As part of it, like Microsoft acquired Citus Data, a Postgres company, reaffirming its commitment and continue to release periodic updates for Citus back to the community. We are also very excited to have Postgres committers Thomas, Jeff, Andres, and David join our team. Having such core expertise in our team is helping us to get a better and deeper understanding of Postgres and also allowing us to contribute back to the community. So with all those rich set of features and capabilities, Postgres is really built for the cloud. And Azure builds on Postgres and makes it easy to deploy and run your Postgres database by adding capabilities such as security, ecosystem integration, scaling operations, high availability, automatic backups, and so on and so forth. So essentially, Azure Database for Postgres is a fully managed, intelligent, and scalable Postgres service. I show this short URL here. So if you want to know more details, please use that URL. So what you can build with Azure Postgres. So I'm going to show some examples of applications that you can deploy with Azure Postgres. First one is like using AKS, which is Azure Kubernetes Service, right? It's basically a fully managed Kubernetes service that helps deployment and management of containerized applications. So you can use or engage cloud native developers and deploy it on AKS with the flexibility and also avail the extensibility of Postgres and build modern applications. You can enable real-time operational analytics where you don't have to have many databases separately for transactions and analytics. You can converge them with Postgres. You can build geospatial data like leveraging PostGIS extension, or you can use time series. You can convert Postgres to be a time series database, and you can make just-in-time decisions based on event-driven applications. So Azure Database for Postgres, we use community version of Postgres and not a forked one. So which means that whatever applications you are creating on the database, you can pretty much port to any other location and continue to run. So how does Azure in a managed service help you building much faster and efficient applications, right? Primarily, the purpose of the managed service is to take care of the basic operations or management of database so that you can focus on your application. Right? So Azure basically ensures your database is periodically updated, automatically updated, and keeps up to date with all bug fixes and security fixes so that you can focus on your application. And it allows you to scale your resources independently, both compute and storage. It is built-in compliance and security. It automatically leverages enterprise-grade security that already built in with Azure. You'll receive like security alerts with advanced threat protection. And last but not least, rest assured that you have the best-in-industry uncapped defense and indemnification coverage from Azure. Let's start looking into some deployment options and some use cases and some applications, how you can deploy with Azure database for Postgres, right? Let's say you want to migrate to cloud or you want to modernize your application, right? So we recently launched a new deployment model in Azure. It's called Flexible Server, right? So currently it is in preview. So I will go over some of the concepts of a Flexible Server and how you can deploy your application with this deployment model. So Flexible Server effectively runs your enterprise workload. Why? Because it provides you maximum control for your database. So though it's managed service and we offer optimized parameter settings and depending on what compute tier you choose, storage size you use, you can still go and tune few things to suit your business and application. Such as like you can configure your network configuration, what clients can access and how it can access. You can tune parameters and you can define what time that periodic updates should happen, right? So essentially, like you can choose the date and time of the week, for example, and that's when like the updates happen. So you can also build resilient applications, so zone redundant, high availability. So essentially, like you are deploying a standby database on a different zone, so to protect from zone level failures. And it's in synchronous mode, which provides zero data loss. And you can co-locate application and database in the same zone for much better performance, right? We also optimized a lot for a simplified developer experience. For example, like it provides a simple end-to-end deployment, right? Very easy to run a command or go through UI to deploy a database. And it's a fully compatible community Postgres. It's not a forked version. And we have cost optimization, such as like a stop and start, where you can, if you're in a development environment and if you don't want to keep it running over the weekend, you can turn off on Friday, for example, and you can start it on Monday morning, right? So that way, like you are not incurring any charges for the compute. When you're deploying a flexible server, you can choose which region you want to deploy and which availability zone you want to deploy in it. So essentially, region is a separate geographical regions, and then each region have different availability zones. And you can deploy your applications, VMs, and databases like to be co-located together. So, you have optimal performance. We are going to spin up a Linux virtual machine, and we install Postgres database in it. So you currently support 11 and 12. And the storage is basically Azure Premium Storage for storing data and logs. That is redundant, multiple copies within the zone for resiliency and high availability. And the periodic backups are done to the zone redundant byte storage. So that backup is available across all the zones within the region. So you can also deploy your applications along with the database for low latency and high performance. So if you want to protect your applications from zone level failures and need the ability to fast failover, you can then choose the zone redundant high availability deployment. So when you choose that option, a standby database is provisioned on a different zone. Asynchronous mode of physical replication is established, and that provides zero data loss in the event of a failover. All application commits and writes on the primary are acknowledged only after the standby received that data and then it's persisted. So this setup basically gives you a good, high availability and faster failover capabilities. So what happens in the event of a failure, right? So let's say like a node crash or a serious networking issue or a serious storage fault on the zone, and then your database is no longer available, right? So the flexible server detects that and it fails over to the standby. The standby server which is basically a replica. It's activated and it becomes a read-write node, and your applications will connect to that, which is a new primary, and they can continue the operation there, right? So, and then a new standby is established on the previous zone that you were previously operating, right? So in this model, it gives you a much faster failover, much lower RTO, and it gives you high availability in the event of a serious fault of the primary. So from networking perspective, flexible server supports two modes of access. So one is using public access. So it is using public endpoint, right? It is resolvable publicly using DNS address, and you can restrict what IPs can access to it using firewall rules. And flexible server also allows private access using VNet integration. Servers in Azure Virtual Network can only be reached and connected through a private IP address. And you can create a separate subnet for deploying your flexible server, and you can define rules on what clients can access that. From the client connectivity perspective, we enforce CLS 1.2 and above. So let's build an application with Azure Database for Postgres. So it's a sample application. It could be a transaction application here, which uses AKS or Azure Kubernetes service. As I mentioned, it is a managed Kubernetes cluster in Azure. You can modernize your application development practices to basically microservice and container-based approach. And on the database side, which is on the middle of your screen, you can deploy a fully managed Postgres and configured with the VNet and zone redundant high availability. And you can offload database demands by managing session state and assets caching with Azure Cache for Redis. And on the left, you can see Azure Functions, where it's a serverless infrastructure, where you can trigger alert based on key events such as user activity using Azure Functions. And on the left, you can see a notification hub, where you can push a notification directly to your users on their preferred service or medium using the service. And Azure Databricks, which is in the bottom of the screen, is an Apache Spark-based analytics platform. It's a big data tool where you can perform deeper analysis of the data. And finally, you can monitor your application performance for degradation or anomalies and auto-scale your application to changing performance requirements. Now, say if your application demands more performance and you want to scale out to hundreds of nodes and handle terabytes or petabytes of data, Then you can choose Azure Database for Postgres Hyperscale Citus deployment. So as I mentioned, Microsoft acquired Postgres company last year called Citus Data. The team created the Citus extension, which is an open source that transforms Postgres into a distributed database that you can scale horizontally. Right? Citus is now available in the cloud as Hyperscale Citus. It's a built-in deployment option in Azure Database for Postgres. So Hyperscale Citus is a managed Postgres database service with data inquiries distributed across nodes to provide unlimited horizontal scalability. You're basically sharding your Postgres database across multiple nodes to give your application more memory, compute, and storage. This is the GitHub page, and visit this page to learn more about Citus extension. So what you can do with Hyperscale Citus, right? First, you can scale out horizontally to, you're no longer confined to one single node. You can scale out to hundreds of nodes. You can ingest data at a real time, with sub-second response, and billions of rows, right, with the blazing performance. It's a simplified architecture, right? So both transaction analytics are, you can store it on the same database. And you can stay current with Postgres innovations. Like, it is based on open source extension. Postgres itself is open source. So you can leverage all your Postgres expertise to its latest innovation. So building an application with Hyperscale Citus. So previously, like, we deployed an application, transaction application, using AKS and flexible server. So if you want to scale out, you basically replace the database component using Hyperscale instead of flexible server. With that, you can basically scale out horizontally, and with more performance and with more nodes. And another application example is the real-time analytics. In this, like, we are basically going to ingest data into Citus, and then how you can connect with other Azure services to avail more value from it. So Azure Event Hubs in the middle of the screen is a big data streaming platform and event ingestion service. You can stream millions of events per second from devices and sensors to it, and then you can build downstream pipeline to process, manipulate, and ingest your data. Ingest those millions of raw transaction events into Hyperscale Citus, it's per second, and which allows you to query and alert on granular events. You can do periodic incremental rollups directly in your database for real-time reporting and also for dashboarding for downstream applications. And you can take advantage of Azure Databricks to clean, transform, and analyze streaming data, and combine that with the structured data from operational database or data warehouse. I can provide insights to users and operators in the on current device status that you can see in the bottom of the screen. And you can push timely notifications to your users on their preferred service or medium. A few components of Azure that you can put together to have in real-time analytics with Hyperscale Citus. So moving on to real-world examples here, right? Microsoft Windows. So Microsoft Windows diagnostic metrics are displayed on real-time analytics dashboard called Release Quality View, and that is populated from Citus. So essentially, they deployed across 2 Citus clusters with 2,800 over cores, with 19 terabytes of memory, right, and petabytes of data. So essentially, like, it is supporting about 6 million queries every day with 2 petabytes of data, and most queries are responded like with less than a second. So this is critical for Microsoft Windows for mission critical ship room decisions. And another example is ASB, which is a large bank in New Zealand. So they were having 40 minutes to onboard customers. And with Citus, they were able to cut it down to 2 minutes, which is 20 times faster. Now, customers, right, their environments are getting complex now. They have tens of hundreds of thousands of applications, such as containers, VMs, databases, right? And they run on diverse infrastructure, such as data centers, hosters, branch offices, and so on. And they also deploy in multi-cloud, right? And with that, they also have applications that cannot move to public cloud due to regulatory and compliance reasons. So in that situation, like, if you want to run Postgres in your infrastructure, because of any of those restrictions there, right? we have a new deployment option. It's called Azure Arc enabled Postgres Hyperscale, which is part of Azure Arc enabled data services. So what is Azure Arc? It's one of the 3 pillars of Azure Hybrid, along with Azure Stack and Azure IoT. So Azure Arc for database data services is offered through Azure Arc, where the infrastructure is provided by the customer, and also customer takes care of the operations, while the software is provided by Microsoft. So what is Azure Arc enabled Postgres Hyperscale? Right. So it's pretty much like Azure Arc makes it possible to run Azure data services on premises, at the edge, and in public clouds such as Azure, AWS, or Google Cloud. Right. So with the software provided by Azure, it is always current. Right. It's automatically updated, and you can scale your infrastructure, using that same automation. Of course, like you are providing the infrastructure, but the software makes it easy for scaling, and provides a unified management, a single view for on-prem and cloud using familiar tools. Azure policy is implemented, and also cloud-based billing, right? It's all like you are going to enjoy all the benefits of the cloud, but in your data center or your preference. So essentially, it can run anywhere using Azure Arc. And the only requirement is it requires Kubernetes, any Kubernetes. And they have a short URL there. You can read more about Azure Arc data services. I'll switch to what's making Azure the best destination for running Postgres applications. Azure Postgres offers a variety of deployment options to choose from, starting with burstable compute to scaling to hundreds of nodes to meet your requirements. Right. So we talked about flexible server, where it gives you control, flexibility, and high availability. Hyperscale Citus, it provides a distributed database with unlimited scalability. And we have Postgres Hyperscale Azure Arc that runs Hyperscale on your preferred infrastructure. When you also have single server, which is fully managed PostgreSQL service. So with that various deployment option, let me go over some of the building blocks making Azure the best destination for Postgres. Right. To start with, Postgres is the best open source database with a large community support, right, and the proven reliability and stability with rich features. Right. And then add Azure's management capabilities. It's fully managed, integrated intelligent performance, highly scalable, highly available, and then you provide maximum control. So that all with a Postgres database, and then you put that all the management capabilities on top of it. And you can add all the integration with Azure ecosystem, right? We provide integration points with, say, Active Directory, Visual Studio, Azure Data Factory, Power BI, and so on, so that you can build your application end-to-end on Azure. So all the Azure services has identity, security, management, and compliance. It's all available in Microsoft Azure, right? And with Azure Arc, you are even extending that same capability to a non-Azure infrastructure too. So far, I covered how you deploy your mission-critical applications on various Azure Postgres deployment modes. To learn more about the latest happening in Citus, Azure Database, and even for Postgres, you can subscribe to this newsletter that I put a short URL here. And also have additional resources that you can take a look into, including that Azure service page and flexible server details. Right? There is a feedback forum and email. So where you want any questions or concerns or any requirements you may have, please feel free to post your questions to either to the forum or to the email. So with that, I conclude the session and hope you found this session useful. We are looking forward to hearing from you, and thank you for your time, and bye.
Hello, and welcome to Building Mission-Critical Apps with the new Azure Cache for Redis Enterprise tiers. I am Amiram Mizne, Principal Product Manager with Redis Labs. I'm very excited to have this opportunity to talk to you at the Open Azure Day event. I've been with Redis Labs just over 2 years now and invested a significant portion of this past year working with the Azure team on these new enterprise tiers for Azure Cache for Redis. Before we dive into these new capabilities, let's frame this discussion a little and talk about what brought me here today. So for those of you that are new to Redis, it is an open source in-memory database or key value store, which means it's lightning fast, especially compared to databases that are write to disk. It makes it ideal for use cases that involve quick user interactions like web session store, job queue management, messaging, and many more use cases, part of what is known as the instance experience. All are enabled by Redis. It is exceedingly popular, has been pulled from Docker Hub over 2 billion times, and voted most loved database by developers for 3 years in a row. Redis Labs is the home and sponsor of the open source Redis project. Just recently, Salvatore Sanfilippo, creator and maintainer, benevolent overlord of Redis, has stepped down, and the project introduced a light governance model with a community-driven core team, including project leaders and core team members from Redis Labs and from other major organizations. And we're seeing increased community participation, growing contributions, and we feel those are key for this type of project. A couple of resources here for you at the bottom of the screen will allow you to explore our community and the tools we have, additional open source project that we support, and loads of free resources, including Redis University, which offer multiple free developer courses. On the commercial side, our product offering is called Redis Enterprise. It has open source Redis at its core, with added capabilities on top to make it even more performant, highly available, geo-distributable, and an overall more secure database. All these capabilities offered as a fully managed cloud service or self-managed software on bare metal, VMs, as well as Kubernetes, while still maintaining compatibility of data types and Redis interface, which makes migrating applications between open source Redis and the enterprise versions of Redis fully seamless. Now, we've joined forces with Microsoft Azure to bring these additional capabilities into Azure Cache for Redis, expanding the ability of the several tiers of service already offered based on open source Redis. If you're listening to this session, you're probably familiar with Azure. It's 58 regions worldwide. It's market-leading certifications from industry standard groups and governments, and top-of-the-line security, not to mention one of the friendliest environments for developers. So when we partnered with Azure to design this new service offering, our two companies and our engineering teams worked together on it and had the following key values top of mind. Number one, improve developer productivity. Second, ensure operational resiliency. And finally, ease the flow from an on-prem environment into cloud, enabling hybrid and cloud migration. Let's talk a little bit of how we do this. First, improving developer productivity. With a fully managed service, we alleviate the need to configure servers and worry about infrastructure. We're leveraging the Microsoft Azure experience by expanding on a familiar, well-established developer toolset. Developers can deploy a new Redis instance within minutes on the Azure portal with a graphical user interface or automate their deployment using Azure Resource Manager templates, Azure CLI, or Terraform. Just like the existing Azure Cache, enterprise tiers instantly and natively integrate with Azure App Service, as well as many other Azure native services, such as Azure Spring Cloud. The Redis resource is fully managed by Microsoft with joint support from Microsoft and Redis Labs support teams. Backed by the Redis Enterprise cluster, enterprise plans simplify Redis client and application lifecycle. Large data sets that would previously span partitions are served by a single endpoint. This capability is similar to Azure Cache for Redis Premium plan, without requiring Redis cluster client implementation or changes in application logic while scaling. Support for Redis cluster API is also included. Now, the enterprise tier expands Redis functionality by supporting multiple Redis modules. Support for additional use cases such as these on the same technology stack flattens the learning curve and accelerates development. These new data types also benefit from the extremely fast and highly scalable Redis architecture. Let's start with Redis Search, which provides superior performance over a variety of search scenarios, which are essential, for example, for retailers moving to and scaling e-commerce. We're introducing Redis Search 2.0 as part of the Azure Cache for Redis Enterprise tier's public preview. And as part of this offering, it allows additional search capabilities and adding them on top of existing datasets. Source available Redis Search is offered as an enterprise supported product on Azure, and you can explore Redis Search IO to learn more about this project. Another popular expansion for Redis capabilities come in the form of Redis Time Series, which enables, for example, Internet of Things and analytics use cases. It is already integrated with many popular tools such as Prometheus, Grafana, and Telegraph. And this most recent version we've introduced supports backfilling capabilities. Those allow you, for example, to batch load historical samples into an existing series or update existing samples, making migration easier. Source available Redis Time Series is offered as an enterprise supported product on Azure. And you can learn more about it in redisTimeSeries.io. Finally, Redis Bloom adds probabilistic data types to Redis. One of their key advantages is getting query responses on an otherwise very large amount of data more quickly, with a smaller data structure in use cases that allow you to give up some accuracy. Again, this source available module is provided as a fully managed service, and you can learn more about it at redisbloom.io. Now let's talk about another aspect, which is operational resiliency and what that means. Operators don't want the burden of deploying new infrastructure or going through lengthy procurement cycles. They want to provide their developers and organizations with tools that work reliably and securely out of the box. As I mentioned earlier, Azure has more compliance and security certifications than any other cloud provider, as well as operating in more regions than any other cloud provider. Now let's look in some more details at the tools available today and what's coming next for the enterprise tier. Coming in public preview that's available today, non-geo-replicated enterprise resources are deployed as a multi-node cluster across multiple Azure availability zones in the deployed region. This provides resiliency to failure of an entire availability zone. Active geo-replication coming later when we go GA provides local latencies with even higher service resiliency and the ability to survive an entire region failure. Today, we can use Azure IAM role-based access control to manage Redis resources, and Redis resources are deployed on an Azure managed VNet with access through public APE endpoints or through private link. Azure Cache for Redis Enterprise Flash is powered by Redis Enterprise Redis on Flash. It creates databases that extend your DRAM capacity with NVMe RAM to store significantly more data with fewer resources, reducing costs. Instead of keeping the entire dataset in DRAM, Redis on Flash keeps only the keys and the Redis dictionary in DRAM, along with the hot values of the dataset. Other values, also known as warm values, the lesser used portion of the dataset, are kept on the local flash storage. This enables deploying large datasets, typically in the hundreds of gigabytes and into the terabyte range, in a more affordable way using less compute resources, making flash plans more cost-effective dollar to bytes. And finally, looking forward into our joint roadmap, our teams are looking at leveraging active geo-replication with conflict-free data replication to enable users to migrate their workloads to the cloud. maintaining persistency and ensuring zero data loss, all while keeping a firm leg on premises. This provides the flexibility of keeping a hybrid deployment model or eventually shifting entire workloads to be fully cloud managed, depending on how business needs evolve. And now let's go to a demo, starting with the Azure portal. Let's go ahead and create a new Azure Cache for Redis enterprise resource on the Azure portal. So I'm on portal.azure.com, and I can search for, or I have Azure Cache for Redis already in my services bar here on top, and hit create. And we can go in here, and I'm going to pick a resource group, region, and then if I go into the available types of resource, I can see we have enterprise tiers, starting from 6 gigabytes all the way up to 100 gigs on the DRAM side, and Redis on Flash from 345 gigabyte and up to 1.5 terabyte. Those are the scale 1 level of sizes. The DRAM sizes scale up to 10 times, and the Redis on Flash sizes scale up to 9 times this size. So for this demonstration, let me pick the E3 DRAM plan, which is 31 gigabytes. I'll give it a name, call it demo 4. And I can simply stop here. I'll allow you to accept terms, but I can stop here and go to review and create, and just hit create and be done if I wanted to. That is the quick option. If I want to choose one of the more advanced options, I can go through it. Networking, and this is still on the private preview environment, doesn't have all the options, but it will have a private link option when you see it in public preview. Now, I want to spend a minute here to talk about private link and how it makes your life as a developer easier. Essentially, unlike VNet injection, you don't have to worry about setting up your network security group and opening the ports that are needed in order for Redis to communicate amongst its nodes or with other services. The entire cluster is deployed on an Azure managed VNet, and all you have to do on your end is open the port to the endpoint, and you're good to go. If you go to the advanced capabilities, we have some new capabilities like modules. You can select one of the modules we've discussed, which expand our use cases in Redis. In this case, I will select Redis Search. Then I have an option to enable clear text access if I want, or just keep it only to TLS secure access. And then we have eviction policy options. Those do not work in conjunction with Redis Search. Let me just unselect this for a minute and look through this. And these are standard eviction policies that you have in Redis OSS that you can choose. But let's go back to where we're going with Redis Search and hit next, and I can select a tag. In this case, I need to do that because my environment requires me to tag all my resources with my name. And finally, I can go and hit create here and get that plan going. Now, I've already created one of these. This will take several minutes, so I didn't wait right now for this to be created. Just to give you an idea of what this looks like once it's up and running, I've gone ahead and used Azure Monitor to add a couple of these dashboards from my resource into my my primary private dashboard. Here you can see how that's seamlessly integrated with tracking, in this case, of average use memory and average operations per second for my cache resource. Now, this is a fully set up resource already. It has an endpoint, it has a port, access keys, everything you expect from an Azure Cache for Redis resource, with the addition of this being enterprise resource and having the Redis Search module installed. So for this next demonstration, we have this fictitious peer distributor called Brutus, and we've created a demonstration of what it looks like on Redis to manage inventory and a search system through that inventory. And it uses streams, which were introduced in Redis Open Source 5, as well as Redis Search to enable it. So in order to do that, I've created an Azure Application Service application, and I've already plugged in my Redis host and my Redis port to enable it. And it's container-based. You can also do that as a Azure Spring Cloud, and I'll give you the link when we're done with the demo, so you can try it yourself. Now, I've launched this application, and I can look for a beer. So I found out recently that this thing exists, and that's it's a Trekkie. I can't resist looking at this and consuming this. It had a little Horgon on it, and I found my beer that I wanted, and I can search for its availability. And that will take me, with the help of geospatial search, to a map. I'm here in Walnut Creek, California, and these are breweries around me that have, the green ones have the beer available, and the yellow ones have it in limited capacity, and I can look in and see that there's 36 of those available, and I can go grab that if I'm so inclined. So what's happening in the background to enable this? So I'm going to show you another tool called Resiliency, which is our free developer UI tool, Redis UI for developers, if you like. And in this case, we see the stream of data that brings in information about the availability and of items that are going in and out of inventory. And you can see it gets updated in real time. Now, as a developer, when you are building an app like this, you can use Redis Insight, scan your keys, automatically find those streams. And as I scan more to this key space, I will find more of these streams. There's a couple of them. And debug any issues and really help with development of my application as I go through this. Same with the search capabilities, natively integrate with search, identify the indexes that are being used by this database automatically. So you can see there's indexes on inventory, on stores, and on products, and then I can execute queries and in real time see the query, how it's structured, do we have the right syntax, and check for the results as I go through the development process. And like I said, this is a free tool that Redis Labs provides, and it has support for other modules as well as doing things like memory analyzing, profiling, and so on. By the way, I'm also running Redis Insight on Azure Application Services. Great way to do that, very easy. Finally, nothing quite like eating your own dog food, or some people like to say drink our own champagne. And we use Redis Search to drive our live redislabs.com website. And in this case, we've integrated it with our documentation site. And as you look through our documentation and you start typing in, you can see, powered by Redis Search, we have auto-completion and very quick search. And this service is deployed on multiple regions across the world and supporting our production websites at Redis Labs. Based on what we've seen, here are some demo resources. Everything I've showed you is available on GitHub with open source license. The Redis inventory management platform with streams and Redis Search, the Redis Labs documentation site, search with Redis Search, as well as our free Redis developer UI, Redis Insight. Looking to the future, and a little bit also about how we got here. So we launched private preview with these enterprise tiers back in May 12th during RedisConf 2020. And those included the Redis modules, which we've covered, Redis on Flash, Redis Open Source 6.0, and it ran with select customers as a free proof of concept and for basic trials. By the way, this was the first version of Azure Cache for Redis tiers that ran on Linux. We've successfully concluded a private preview and began our public preview offering on October 30th. This offering comes with 4 nines availability when deploying over multiple availability zones. Includes private link, includes Azure billing. The service is very much like a first-party service built by Azure and managed by Azure. It is already a production-grade service, albeit it's available in select regions. As we move to GA early in 2021, and there's a typo here, we'll have active geo-replication offering 5.9 availability with multi-region support. And as a GA offering on Azure, it will be available on all Azure regions. Finally, I'd like to thank the Azure team for hosting me today, and thank you for listening. If you want to get started today, you can go to aka.ms/Redis Enterprise or search for Azure Cache for Redis on the Azure portal and get started. Thank you very much.
Hi, everyone, and thank you for taking the time to join our session today, where we're going to be talking about architecting secure enterprise-ready solutions for the cloud with Azure and MySQL. My name is Andrea Lamb, and I'm a Senior Program Manager on the Azure Database for MySQL and MariaDB team, and I'm very excited to be here today to talk to you about this topic. In this session, we're going to be covering a few key components. The first, we're going to be talking about the Microservices Architecture. Next, I'm going to introduce Azure Database for MySQL and actually give you a sneak peek into the Azure Database for MySQL architecture. Next, we're going to talk about securing your data. And finally, we'll talk about some of the new innovations our team has been working on. First, let's go over the microservices architecture. In microservices, we typically see customers splitting out the stateless front end from the stateful back end. And this architecture here that I'm showing you on the slide is actually based on one of our real-life customers. And they use this to support millions of banking transactions daily. And we see them using microservices running in different containers, with Docker being their most preferred technology. First, they want to consider how to manage a large scale of microservices. And they use this and manage this using some form of container orchestration in Kubernetes. In Azure, we offer the Azure Kubernetes service, which can be used to manage your microservices. From there, they want to ensure that all of this gets encapsulated in a network boundary. And this ensures that you're protecting and having some form of network isolation and ensuring that you are able to monitor who has access to the application and how to protect your data. So now that we talked about the stateless front end of things, let's talk about the stateful component of the application. This is where PaaS offerings typically come into play and also provide some type of open source technology. And this can be used as a persistent data store for your application. And on top of that, in Azure, we also have a ton of really great analytic tools that can be used to integrate with your data storage, allowing you to perform additional analysis and help to make data-driven decisions. So what's the advantage of the setup? Well, when you're splitting your application across different services and modules, this allows you to scale each component individually and allows you to scale to grow your demands for your particular workload. Another benefit of using a persistent PaaS layer is to help alleviate some of the manageability headaches that may come with it. And this includes the ability to perform automatic backups and maintain high availability, to name a few. And finally, when you're using a PaaS layer and building on top of the security tools that are available in the cloud provider, you can take advantage of some of the key innovations that we here in Azure are helping to provide our customers with. So when you think about the stateful PaaS layer, what are some of the requirements that you should be considering? Well, first, you want to think about something that is truly a fully managed solution. And this includes the ability to provide automatic backups, built-in high availability, resiliency, and disaster recovery tools. Another thing to think about is how to scale on demand when you need to, and this ensures that your application is able to meet the workload's needs. And this can be done using a couple clicks of a button in the Azure portal or using some simple Azure CLI commands. From there, you might want to also consider the different security, tooling, and compliance certifications that a particular service has. And so many of you may be thinking about PCI, HIPAA, or FedRAMP, to name a few. And then when it comes to developers, we really want to make sure that many of these services are integrated with each other. This ensures that you as a developer don't really have to think about how to do this additional integration yourself. And then we also want to make sure that many of the tools and frameworks that you're already used to using can all be used directly against these PaaS services. Lastly, cost efficiency is something that's top of mind. And this includes things like stopping your server over the weekend and then starting it again when you're back in the office on a weekday. And then also things really around low prices in terms of providing you with dev test queues, to name a few. So now that we've talked about some of the requirements of a PaaS layer, I now wanted to introduce Azure Database for MySQL, which can help with meeting some of these requirements in terms of data storage needs. Azure Database for MySQL is a fully managed database service here in Azure, and it's integrated with many of the different Azure services we have available. One of the great things about this MySQL service is we're actually running the community edition of MySQL. So many of the tools and frameworks that you as a developer are already used to using against MySQL can all just be re-leveraged. Secondly, the MySQL service comes with a built-in high availability SLA, and this is money-backed with 99.99% high availability. And this also ensures that you have the lowest total cost of ownership because you don't actually need to stand up a second server in order to get that high availability. We offer it for every individual server that you provision. And as I mentioned earlier, Azure also keeps in mind that security is one of the top priorities for you and for us. And to help with that, we offer things like advanced threat protection, which we'll talk about a little bit later, which provides you with some of the latest innovations that we've been working on in the security space. Next, there are also some great built-in intelligence features that we have, and this includes the Intelligent Performance suite of features that we have that allows you to get more insight into some of the query performance that you have on your server and offers recommendations on how we can potentially improve your performance on the server as well. And like I mentioned, integration with other Azure services is also super important as it also helps to simplify your life as a developer and integrate with other things like the Azure App Service or Power BI. Next, I wanted to give you a sneak peek into the Azure Database for MySQL architecture and give you a little bit of a better idea of how we can actually offer you that 99.99% high availability SLA. So as you can see here on the right side of your screen, we have an MySQL application that's trying to connect to an Azure Database for MySQL server. First, the connection is routed through our gateway, and the gateway sits in front of all of the backend nodes in our service. From there, the connection goes to the gateway, and then the gateway interprets the connection string and is able to then route that connection to the appropriate MySQL server running on the backend. That MySQL server is also connected to Azure Storage. Azure Storage is what we use to host all the data files and backup files for your particular server. And we also have the Azure Database Management Service, which is used to detect any issues that may be running in your server and also helps with facilitating any failovers. Next, I wanted to highlight what happens when something goes wrong with one of the data files. So when we detect that, what we then do is then switch over your MySQL to point to a different data file that's hosted within Azure Storage. As I mentioned earlier, Azure Storage keeps 3 copies of those data files on your behalf. Next, I wanted to highlight what happens if something might go wrong with the MySQL server itself. The Azure Database Management Service can detect unhealthy nodes, and from there it will stand up a new MySQL server, and then the gateway gets rerouted and points now to the updated server hosted in the backend for your MySQL server. And from there, we definitely recommend having retry logic built into your application to reconnect, and then once the server is back up and running, it will continue that connection. So now that you've learned more about microservices and Azure Database for MySQL, I wanted to show you how all that comes together. And to do that, I wanted to use Magento as an example. Now, Magento is an open source e-commerce solution developed in PHP, and it actually uses MySQL to store its application data. And I'm going to use Magento to now highlight some of the traditional security gaps that might come with hosting your application and database in the cloud. The first is really around having your services and traffic be exposed to the public internet, leaving them vulnerable potentially for security breaches. The second is around how you store your data, both at rest on your database as well as in storage drives. And these can be attractive targets for attackers and can potentially be used for data exploitation. The third is really around granting users the correct access to the different resources that you may have in a timely manner. And the fourth is really around detecting unusual and harmful attempts against your data. So now that we've talked about some traditional security gaps, I now wanted to highlight how Azure Database for MySQL's innovations can help protect against some of those gaps. The first is really around network isolation, and to do that, we provide varying levels of isolation for different networking solutions, and this includes Azure Private Link as well as virtual networks. Secondly, when it comes to data security, we do provide data protection both at rest and in motion. And this is done through SSL and TLS enforcement, data encryption at rest using custom managed keys, which allows you to rotate your keys as you need. Infrastructure double encryption, which is in preview, which gives you an additional layer of data encryption. The third was around access control. And to do that, we offer Azure AD authentication, which uses a token-based authentication method to connect to your Azure database from MySQL Server. And the fourth is around preventing and monitoring unusual activities. And for that, we have the Advanced Threat Protection Preview, which can be used to monitor and alert you for any unusual activities that may be happening on your server. And we also offer audit logging, which allows you to track database activity and provide that as evidence for different compliance certificates that you may have. Next, I wanted to highlight some key points for you to take away from this session. The first is really around Microsoft's commitment to making Azure the most secure cloud for all of your data and application needs. Secondly, Azure Database for MySQL offers a bunch of really great enterprise security controls, which are aligned with industry security controls to help you as a customer quickly, efficiently, and effectively meet applicable security and compliance requirements. Third, security and compliance is a shared responsibility in the cloud. And for that, I definitely recommend that you check out the shared responsibility model, which I'll link for you at the end of this session. Next, I wanted to talk to you about some of the great new innovations our team has been working on. Recently, we introduced the preview of Flexible Server, which is a new deployment option for Azure Database for MySQL. It offers three big key components. The first is really around maximum control for your databases. And this offers you the ability to actually deploy your server within a virtual network by delegating a subnet to your MySQL flexible servers. We also offer server parameters for giving you more fine-grained tuning for your particular workload's needs. And we've also introduced custom maintenance windows, which allows you to tell us when you can actually receive maintenance against your servers. The second is really around building resilient applications. And for that, we offer zone redundant high availability, allowing you to stand up a hot standby in another availability zone. And this helps with preventing zero data loss when we perform fast failovers, and also allows you to co-locate your application to an availability zone to help with minimizing network latency. And the third is really around a simplified developer experience. And for that, we went through every Azure portal screen that we have, as well as every Azure CLI command that we have available for Flexible Server, and tried to simplify those as easily and as best as possible. We also offer MySQL using the same Community Edition that we have in our existing service. And we've also introduced great new features around cost optimization. This includes Stop Start and Burstable. Stop Start allows you to stop your server and then restart it when you need to, so you can stop that over the weekend and restart it when you're back in the office on Monday. And also offer Burstable as a new compute tier. And Burstable is really great for some workloads that don't need that CPU consistently throughout the day, and allows you to bank up credits and then with that spike up to 100% CPU. Flexible Server is a result of much of the feedback that we've received from our existing customers, so I really thank you for the feedback that you've provided us, and definitely recommend that you go check out this new preview today. Last, I wanted to leave you with some great resources to get started. So definitely check out our MySQL documentation to look through some of our quick starts, learn more about the features that we have available, and also recommend that you check out the cloud shared responsibility model that we discussed earlier to learn more about the different responsibilities that you as a customer have, as well as us as a cloud provider. And I also recommend checking out our Azure Database for MySQL blog to learn more about the Flexible Server announcements that we recently made. And if you have any questions about Flexible Server or anything that we discussed here today in this session, please feel free to reach out to us at AskAzureDB for MySQL at service.microsoft.com. And also follow us on Twitter to keep up to date on the latest announcements for features that we're working on. And with that, I wanted to thank everybody for taking the time to watch this session today. I hope everybody is staying happy and healthy.
Hi everyone, welcome to the session on how Minecraft frames migrate to Azure MySQL for improved gameplay, better interoperability, and cost efficiency. I'm Amol Bhatnagar and I work as a product manager on Azure Database MySQL and MariaDB services. Prior to joining Microsoft, I have worked as a software designer with Hewlett Packard Enterprise, and I have also done my master's from Carnegie Mellon University. So let's go and see why Minecraft migrated to Azure Database MySQL and what are the benefits you can get when you migrate to Azure Database MySQL. So as you know, Minecraft Realms is one of the world's most beloved games with millions of monthly active players. This migration for Minecraft Realms was basically motivated by three factors. The first one was the cost efficiency. The second one was the better interoperability with the Microsoft ecosystem. And finally, the third one was the improved gameplay through lower latency with Azure Database for MySQL. So these were the three reasons why Minecraft Realms migrated to Azure Database for MySQL. So with Azure Database MySQL, you can also easily lift and shift your workload because Azure Database MySQL runs on the community MySQL engine. So if you are hosting your servers on AWS RDS MySQL, or if you are on any other cloud provider or MySQL on-prem, then you can easily lift and shift your workload to Azure Database MySQL. The another factor is the enterprise readiness. With Azure Database for MySQL, you will get the elastic scaling with high availability and the secure and compliant through the features like data encryption. The industry reach of Azure Database for MySQL and the integratedness with the services like Azure Kubernetes services make Azure Database MySQL developer productive and friendly. So let's take a step back and see the Minecraft Realms architecture on AWS RDS. So Minecraft offer both single player and multiplayer mode of gameplay. Minecraft Realms enables player to create personal multiplayer servers, providing a private online multiplayer gaming experience. Originally, as you can see from the architecture diagram, Realms was completely hosted on AWS. This included their cloud-hosted multiplayer game servers, word state data storage, subscription and metadata databases, along with the service code compute fabric. So moving this critical workload for one of the world's most beloved games with millions of monthly active player was one of the daunting and even risky tasks. So let's see how Minecraft Realms migrated to Azure ecosystem. The entire migration was planned, executed in two phases. The phase one consists of the cloud-hosted multiplayer servers. The phase two was the lift and shift of the workload migration, which basically included the realm databases, subscription databases, word state data storage, and the compute fabric layer. So as you can see in the architecture diagram, the phase one, which is migrating cloud host multiplayer servers. As you know, Minecraft Realms hosts tens of thousands of multiplayer servers in the cloud. These servers are dynamically allocated as per the user demands, and these servers are allocated and reclaimed as demand waxes at waits. So during phase one, the initial architecture, the Minecraft Realms was hosted in AWS EC2 instances, and then they moved to Azure Platform Managed multiplayer hosting services. So this was a phase one migration. In phase two, the phase two migration was considered a lift and shift of the workload. For this, Minecraft Realms moved to Azure Database for MySQL utilizing data migration services. The lift and shift workload migration basically was comprised of three major components, which include the database, storage, and the compute migrations. Breaking up the migration into such phases and the component wise help Minecraft migration less risk and without any visible changes to the users. So this was all about Minecraft migration to Azure Database MySQL and how Minecraft utilized data migration services and divided their migration into phases with minimal downtime and minimal impact to their user base. Now let's see what all other options are available to migrate to Azure Database for MySQL and how one goes to migrate to if they want to migrate to Azure Database MySQL. With Azure Database MySQL, if you are migrating, the first step is the pre-migration step where you have to discover which database and server you have to migrate. You have to access your database schema and see if it is right fit for Azure Database for MySQL. Then you have to migrate the schema. These are the pre-migration steps which you have to perform while migrating to Azure Database MySQL. The another phase is the migration tools, which you can basically use to migrate to Azure Database MySQL. The migration tools consist of first the dump and restore. This is basically offline migration, which gives you an ability to migrate offline your all the data from the source to the target Azure Database for MySQL. We will touch base on basically these different tools in the later slides. The another tool to migrate your data is basically the native logical replication, which is an online migration. And this migration basically keeps a very small downtime migration to your application. Again, we will have slides to discuss more about this migration option in detail in the upcoming slides. The another option which Minecraft also utilizes is the Azure Database Migration Services. It's an online migration, and it's cause a minimal downtime to your application and migrate your application without any visible impact to your users. So the last phase is the post migration phase. In this migration phase, basically you will be optimizing while you are migrating to Azure Database MySQL. You will be looking whether the function whether all the data has been migrated by running the functional and performance tests. So the post migration tasks help you to make sure that you have migrated successfully and all your data has been reached to Azure Database MySQL. So as discussed, let's move to different option and deep dive on different tools available with while you are migrating to Azure Database for MySQL. The first tool, as we discussed, was MySQL dump and restore. As we have already discussed, MySQL dump and restore, dump and load databases into Azure Database MySQL. The downtime for this tool, if you are using this tool, is for the time of the migration running. So basically, if you are using MySQL dump and restore to migrate to Azure Database MySQL, the downtime will be caused for the time the tool is running. And we always recommend to use a pricing tier and some server parameter, which I will be going through in the next upcoming slides in details, to utilize those server parameter and the pricing tiers so that you get the highest performance while you are migrating using dump and restore, and you cause a least downtime during this migration. We have also linked to some of the resources. The first resource basically talk about MySQL dump and restore, and the another resources and then the slide talk about the migration server parameter and the pricing tier for MySQL dump and restore and faster data loads. The another tool in this category is MyDumper and MyLoader. MyDumper and MyLoader is exactly same when you come and compare with MySQL dump and restore in regard to the downtime. The MyDumper and MyLoader will still cause the same downtime, or with in another word, we'll call the downtime for the entire time the MyDumper and MyLoader is running for migrating your database from the source to target. The difference and the important difference with MyDumper and MyLoader is that this MyDumper and MyLoader tool is multi-threaded, and it enables you to have a multi-threaded data import and export, which exponentially make the data import faster and cause lesser downtime for your application. Again, we have a blog on the best practice of MyDumper and Loader. I have included a link for MyDumper and MyLoader blog, and along with we have the same set of recommendation for choosing the pricing tier and the server parameters, so that you can load your database and from the source to Azure Database MySQL much faster. The another tool in this category when you are looking to migrate from your source to Azure Database from MySQL is data in replication. The data in replication is different from MyDumper and MyLoader and MySQL dump and restore in a value where data in replication cause a very short downtime. The short downtime is caused at two times. The first time while you are creating and taking a dump of the database of your source server. The another short downtime is caused while you are shifting your connection string from your old MySQL server to Azure Database for MySQL server. So we have also have some of the resources for data in replication, where you can go and learn more about how data in replication works with Azure Database for MySQL. The first link talk about how you can set up the data in replication. The second link basically talk about the same server parameter and the pricing tier recommendation which we provide, so that you can have faster data loads and you can migrate faster to Azure Databricks for MySQL with minimal downtime to your application. Next, let's move to the server parameter recommendation, which I was talking while I was discussing all the options for migration, which include MySQL dump and restore, MySQL data in replication, and my dumper and my load. So these server parameter are recommended, has the recommended value, and basically we recommend this server parameter so that you can have a faster data load with Azure Database for MySQL. The first server parameter in this category is maximum allowed packet. So the maximum allowed packet is to prevent, this server parameter is used to prevent any overflow due to long rows. And we recommend to set this value, the value of the max allowed packet, to 1 gigabytes. The another server parameter is the slow query log. Slow query log, basically this parameter, what helps this parameter provide is basically this parameter turn off the logging of the slow queries, which eliminates all the overhead during the migration. So we recommend to disable this parameter by setting it to off during migration. The similar recommendation on the line is for query store capture mode. We also recommend turning off query store capture mode so that all the queries and all the overhead caused by capturing those queries in the query store will be eliminated during the migration. Just set the query store capture mode to none during the migration, and it will not log any of the queries to the query store. The another recommendation is to use the InnoDB buffer pool size, and we recommend here to increase the InnoDB buffer pool size. And the only way you can increase the InnoDB buffer pool size is to scale up the SKU. So we recommend during the migration, you can scale up the SKU to memory optimized 32 vCore. This will help you to quickly ingest the data into Azure Database MySQL. And when you are done with the migration, you can scale back to the SKU which was desired for your workload. The another two parameter are basically InnoDB IO capacity and InnoDB IO capacity max. This two parameter improves the IO utilization to optimize migration speed, and we recommend to set the value of these two parameter to 9,000. The another parameter is InnoDB write IO threads. This parameter also increases the speed of the migration, and we recommend to set the value of this parameter to 4. The last parameter, or I would say this is not a parameter, the last recommendation basically is to increase the IOPS. Increasing the IOPS make the speed of the data ingestion into Azure Database MySQL much faster, and we recommend to increase the IOPS. The only way you can increase the IOPS, and the point to note, is basically increasing the storage. And you can increase the storage, and you can get 3x of the storage as a IOPS. So if you have 100 GB or 200 GB of storage, you can get 600 IOPS. So we recommend increasing the storage to get the higher IOPS. One point to note here is basically that if you increasing the storage, you cannot scale back. So if you are, so we recommend increasing the storage by few gigabytes, and see the migration data ingestion speed. And see whether it is improved and under the requirement of your downtime, and migrate to Azure Database MySQL. So these are the parameter recommendation plus some of the best practices which we have seen with many of the migration which we helped customer. So you can use this parameter utilize for faster data loads. So with this, we are at the end of our presentation. And I put some of the MySQL resources where you can get the details which we have discussed. The first one is a single server docs. You can go to this single server docs and get all the details. You can also read about Minecraft CRM's migration blog. And if you have any question, please feel free to reach out to us on Ask Azure DB for MySQL at service.onmicrosoft.com. So thank you everyone for attending this session.
Good day, everyone, and welcome to our session on Apache Kafka on Confluent Cloud for Azure, a fully managed service. My name is Kai-Jin, and I'm a solutions engineer with Confluent based in Singapore. I'll be your presenter for today's session. Before we start, a quick introduction to Confluent. Confluent was founded by the original creators of Apache Kafka back when they were still at LinkedIn, and in fact, Confluent was LinkedIn's first corporate investment. Kafka is currently in production at multiple industries across multiple verticals and is in use by the majority of the Fortune 500. For those of you who may not be so familiar with Kafka, Kafka is a modern distributed platform for data streams. Now, we'll get a bit further into what that means later, but let's just start off by taking a quick look at what Kafka offers. So Kafka brings you the best of multiple worlds. It gives you the guarantees of a database, including things such as ordering of the data, as well as persistence. Kafka is highly scalable in both terms of the data throughput as well as the amount of data persisted, and it can run easily on commodity hardware, meaning that you have a choice of where to run your deployment, be it on-premise or in the cloud, including what we'll be going through today, which is the fully managed service on Azure. Kafka is distributed by design, and that means that it includes guarantees such as data replication, fault tolerance, as well as partitioning, which allows you for easy scaling of both your producers and consumers. If you look at the diagram on the right side of the slide, you can see that putting Kafka into your data pipeline allows you to decouple your data producers and consumers, allowing you to easily add or remove new data sources as well as new applications that consume and work with that data. Now, if you're wondering why Kafka was created in the first place, it was because we realized that every organization uses a wide variety of software systems today to deal with their users, their customers, and the data and transactions that are flowing into the organization. Now, one of the challenges when you have such a multitude of software systems in your environment is providing a way to interconnect these systems to allow the data to flow from one system to another, including across domains, across different applications, across different teams that own the data, that control things like data formats, data science, analytics, and BI, and so on. And that is where Kafka comes into play. With Confluent Cloud on Azure, what we've done is that we've re-engineered Apache Kafka for the cloud. And what this means is that much like any other native Azure service, this gives you all of the cloud native experience that you've come to expect, such as the effort of a fully managed service on Azure, meaning that you don't have to worry about deployment, about rolling upgrades, about monitoring, or about alerting. All you need to do is point your applications at the data platform. With Confluent Cloud on Azure, what you get is a fully complete platform, which includes not only Kafka, but all of the features that Confluent has brought over the years, including things such as the schema registry, pre-built connectors, stream processing with KSQLDB, and so forth. You can run this anywhere, including in any of the Azure cloud regions available globally, with full security and compliance, meaning that this is going to be something that's going to be suitable for all of your sensitive data, critical applications, and anything else that is subject to security and compliance requirements. And keep in mind that this is going to be delivered, again, fully managed, which means that your team doesn't need to be worried about things such as ensuring security and compliance. It comes as part of the offering available on Azure. Now, this is going to be fully flexible, much like any other cloud service. You decide the scale that you want, the SLAs, whether you are comfortable with working on a multi-tenant environment, for example, if you are doing exploration or early development, or for those critical or compliance requirements when you need your cluster to run on dedicated hardware. And just like any other cloud service, it is fully elastic, allowing you to scale your deployment to meet your workload requirements without having to worry about things such as hardware procurement, new node deployment, installation, and so forth. Now, the difference when it comes to Confluent Cloud on Azure is the seamless integration that's available through the Azure portal, marketplace, as well as other forms of managing Azure, such as the CLI and API. With our recent announcement of our strategic integration with Microsoft Azure, we are now able to offer you single sign-on from the Azure portal directly into your Confluent Cloud environment using your Azure AD identity, which means that you don't need to worry about maintaining a separate set of logins, user credentials, and when you need to access the Confluent Cloud UI, it's as simple as clicking a link from your Azure Resource Manager. With our integration in Marketplace, you get what you're used to with any other marketplace offering our native Azure service, including seamless billing with Azure Marketplace, which means that you don't have to worry about a separate procurement channel and you can draw down on any existing investment or commits that your organization has made into Azure. The newest integration comes with the portal integration to Azure, allowing you to manage your Confluent Cloud environment from the Azure Resource Manager as well as the CLI and API, just like any other native Azure service. And you can actually see this in the screenshot just below on the middle of the slide. And with this, it allows you to seamlessly provision environments from your Azure Resource Manager and, as mentioned earlier, to log in with single sign-on from your Azure portal into the Confluent Cloud UI. So from deployment all the way through to use, you don't have to worry about setting up a separate subscription. You don't have to worry about creating a Confluent Cloud identity. You don't have to worry about signing up again. All of this is seamlessly integrated, and the aim is to deliver you, the user, a seamless and frictionless experience to use Confluent Cloud on Azure alongside any other native data services that you may have or that you may already be considering to use on Azure. Now, what this means is that what you're able to deliver with Confluent Cloud on Azure are multiple use cases, including on-prem to Azure data streaming, especially if you're considering things such as cloud migration or data warehouse modernization. You're able to leverage real-time data analytics, integrating Confluent Cloud on Azure with other native analytics services available on Azure. And you're even able to cater to native, cloud-native app deployments on Azure. So just to give a quick example of a couple of these use cases, firstly, let's talk about the use case of cloud migration. Now, cloud migration is a use case that we hear very often today across many organizations in multiple verticals, for example, from banking, retail, digital native industries, public sector, and so on. Now, across all of these verticals, the common theme is wanting to make use of the flexibility and elasticity of cloud services. However, there's a great challenge here because it's not as easy as it sounds to simply lift and shift large amounts of data from on-premise, including from potentially legacy systems and multiple points of integration into the cloud. And this is where Confluent Cloud on Azure comes into play. Confluent Cloud on Azure allows you to easily modernize on-premise data services and applications with our pre-built connectors for both third-party systems on-premise as well as for native Azure data services, allowing you to build a seamless pipeline from your on-premise to your cloud in Azure, bridging across your hybrid cloud environments. This allows you to increase the agility across your whole environment while also leveraging your cloud services to reduce TCO and to reduce operational effort so that the development team's efforts can be focused on generating business value rather than on operations such as maintaining day-to-day performance, doing deployment, doing platform maintenance, and so on. Once your data is in Azure, you can also use Confluent Cloud together with native Azure services to derive insights from your data in real time. Now, if you compare this to what many of us may be doing today, which is batch-oriented processing and point-to-point messaging is very unscalable, and it makes it difficult for you to get accurate insights on what's going on in your environment, especially when you're talking about customer-facing functions such as Customer 360. With Confluent Cloud and Azure, you're able to ingest and process streaming data from multiple sources, not only including on-premise, as we've just discussed, but also from multiple sources such as mobile, web applications, IoT, and so on. You're able to use Confluent Cloud on Azure to pass all of these events and messages into Azure services such as Azure Data Lake, as well as analytics on Azure, including advanced use cases such as training, machine learning models, and serving results of your analytics through visualization. To give an example of what some of our users are achieving with Confluent Cloud on Azure today, one of our most successful joint customers for Confluent Cloud on Azure is Bosch. And some of you may know Bosch for their line of power tools. But what we are going to focus on today other challenges that Bosch has been able to overcome by using Confluent Cloud on Azure. Now, one key thing that you may already see on this slide is that Bosch was working with a very limited set of resources in terms of having a very small group of architects, and therefore they wanted to leverage cloud and the fully managed experience as much as possible. And this is where Confluent Cloud, together with Azure, was able to deliver exactly what they wanted with the fully managed offering for Apache Kafka on Azure, together with Confluent's fully managed as well as pre-built connectors, allowing the team to quickly integrate existing systems and to bridge hybrid cloud, as well as performing stream processing on data in flight. Just to give an example of how other customers of Confluent Cloud on Azure are benefiting from the fully managed experience, you can have a look at the couple of customer testimonials on the screen right now. Now, I'm not going to go through the whole of the content, but if you just look at this, what you'll see as a common point is that many organizations are looking to leverage existing data from on-premise as well as legacy systems and to move that data to the cloud and integrate it with cloud-native applications and new applications and services. At the same time, they want to limit or control the amount of operational effort and overhead that brings. And the key focus here is that when you go into any fully managed service on the cloud, what you're really looking for is that you want your developers and your application teams to be really focusing on what's important. And that would be developing and creating applications, analytics, and business logic to maximize the value of your data rather than to be spending time on mundane tasks such as platform deployment and maintenance or scaling. And that is exactly what the fully managed Confluent Cloud on Azure service brings to you. To learn more, you can visit our website at confluent.io/Azure. And thank you for your time today.